look at arithmetic sequence. An arithmetic sequence and generically can be written in this fashion right here. They use the same letter because there's so many numbers in the sequence, they don't want to use different letters. So they choose one letter, A's, B's, whatever it is. And then they have a subscript on it. The subscript itself just tells you what position the number is in the sequence. A sub 1 means that this number, whatever is here, is the first number in the sequence. A sub 2 means I have a number that's in the second position. A sub n is some number in the nth position. N minus 1 just means it's the number before the one with the n position. So that's what it means. This is the number before it. That's what this little subscript here means. And we use it to determine where something is in a sequence. When you did this in earlier lessons, and we had a sequence of numbers, and we put it into a table, these were the numbers that went on the input. And we can do the same thing here. If I wanted to put an arithmetic sequence into a table, then I have the first number in the sequence would be whatever A sub 1 is. The second number in the sequence would be A sub 2, and so on. That's literally what it means. Okay? That's all a subscript is. It just means position. How do I know if a sequence given to you, and I don't tell you what it is, if it is an arithmetic sequence? Well, that's where the definition comes in. An arithmetic sequence, this right here, is a sequence, and I'll abbreviate sequence, of numbers where the difference between any two consecutive terms is the same. And that consecutive number is called, so in other words, we're saying A sub 2 minus A sub 1 will be some common number, D, and then A sub 3 minus A sub 2. So we take the two numbers, consecutive numbers, that means next to. If I subtract them, this one minus that one, I'm going to get exactly the same number. Any two numbers anywhere that are next to each other, if you subtract them, you will get the exact same number. This number then is called the common difference. So D is called the common difference. And if you think back to when we did this in the last unit, I can't spell today. My brain is. Okay. Common difference. When we did this before, that's one of the processes we did. We kind of took these two numbers and we subtracted them, and we got a number down here, and we looked to see if it was the same number each time. That was called, is now called the common difference. Okay. A sequence is an ordered list. Because it's an ordered list, like I was saying up here, we can easily put it into a table, just like this. This would be the position number n, and this over here would be the A sub n, or what we call a generic term in the sequence. And it just keeps on going, and I can keep going and plug in as many ones that I want. I'm going to put this in here so you can see it. And it just keeps on going as far as I want. N, and then this is A sub n. So this would be like your rule would be right here. And so once I have a table, then I can graph this data and see what it looks like. Since it's a sequence, if I graph a sequence, it will display as a discrete graph. And what is a discrete graph? It is just a series, it's just the dots. Do not put or draw a line, okay, between them. This will be linear. It will be linear in nature. It'll be linear in the way it looks, but it's just a series of dots. There is no in between. Okay, so that's why it's called a discrete graph. You can see that it's all lined up nice and pretty, and it would look something like this in an example. I would have a dot, a dot, a dot, a dot, just like that, if you graphed them out. That's one possibility. They can go downwards, they can go flatter, but this is just an example thereof. There are two types of rules we're going to be following. The first one, you were hinted at both of these last time. I kind of talked about them both, but I'm going to now formalize the word and the name. The first one is called an explicit rule. An explicit rule is a rule based off of position. Rule based on position. That's the first one. So if I want the value of this what's in the sequence, find the pattern, and I want to know what value is in the 10th position, then there's a rule that gets me right to that answer automatically. That is the explicit rule. The other form of the rule we're going to look at, and I called it in the last unit, I call it the pattern rule. Remember the pattern rule? Well, its formal name is this. It's called a recursive. The recursive rule. And this is based off of the pattern. This is your rule based on a pattern. And I'm going to show you how to do each of these right now. So let's start off with the pattern. Let's do the explicit rule. So let's look at the explicit rule in more detail. This is how you will find, if you know it's arithmetic, you need to know a couple of things. You need to know the common difference. You need to know the common difference and one number in the sequence. By position. So in other words, I just need one. So I can be the first number in the sequence. It could be the 10th number in the sequence. Doesn't matter. I just need to have a number in the sequence. But I got to know what position it's at. All right? And the common difference. If I know that, then I can do this. Most of those ones, and your textbook is one of them, they'll give you this rule based off of the first number in the sequence. So position number 1. I'm going to go beyond that, and I'm going to show you how to find it from any point in the sequence. Okay? So from the first position, using the first term, a sub 1, here's how you find the rule. So the rule will be, and they designate it as a sub n for an arithmetic sequence. So the answer is, that's the output right there. And here's the rule, and I'll explain this rule to you here in a little bit. A sub 1, that's the first number in the sequence, plus the common difference times, and then n minus 1. Now, if you think back to when we did this in the previous unit, once we found that number that was added each and every time, that number got multiplied to the position. And then we had to add or subtract a number. That number was the common difference, and you multiplied it to a position. And then you added or subtracted a number. That's what this rule is showing. Okay? It's just showing you how to get that number more easily. So you want to know this rule. Know that it's based off of position. This right here, let's do the general one. Using, and they call it the kth term. Okay, so that would be a sub k. This is any term in my sequence. And you'll see that the rule is very similar. The rule will be a sub k, that's the answer for the kth term, the common difference, and then n minus whatever k was. That's a position. So this number right here is the kth number in the sequence. This is position K. And this number is the common difference. That's what these things are. So this is the case number in the sequence, and so forth. So let's look at an example here for this one. I want to show you it. Not that one. Let's make one up. So let's take 3, 5, 7, 9, and so forth. So the first thing you have to do is determine whether or not this is going to have a common difference. You literally just subtract these two numbers. So 5 minus 3, 2. 7 minus 5, 2. 9 minus 7, 2. So this is going to keep repeating. So we have a common difference of 2. You just need any number in the sequence. The first position in the sequence, if you want to use that one, is 3. So the first position in the sequence is 3. The second number in the sequence is 5. The third number is 7. The fourth number is 9. If I use the first position right there, then I will use this rule. My rule is going to be the number in the first position plus the common difference times in the input minus position 1. That's the first number in the sequence, and that means position 1. That's what it means. If I work this out, I get 3 plus 2 times n minus 2, because I have to distribute this 2 multiplies to each of these numbers. Combining these two like terms right here gives me 2n. 3 minus 2 is plus 1, and that is my rule for that sequence. Now, to show you that it works for any number in the sequence, we'll pick a different position value. Let's take the 4 and the 9. In this case, 9 is some number in the sequence, and 4 becomes the new position. So then that rule would be the number in the sequence, the common difference times n minus whatever position that number was in. Position 4. Same thing, we can distribute this out. There's the 9, there's the 2n, minus 8. 9 minus 8 is 1. So you can see no matter which number I take in the sequence, I'm going to end up with the same rule for the sequence. So the textbook will show you only this way. This is much more powerful. I can use any number in that case. Makes it a lot easier to do. This is how you find an explicit rule for an arithmetic sequence. Find the common difference and then use some number in the sequence to find the rule. So what's recursive? How do I do that one? So the recursive rule is based off of a pattern. It's based off the pattern. I still need the common difference. So you have to determine that it is indeed. So I need the common difference. And I need position 1. So you need position 1 and you need the common difference to write a recursive rule. Okay? The recursive rule comes in 2 parts. There are 2 things you have to write the rule correctly. The first one is the first number in the sequence. So you have to establish the first number in the sequence. So you have to say a sub 1 equals whatever that number is. That is part of the rule. Okay? And then the next rule is a pattern. So you, most of the time in this situation I gave over here, the pattern is you add 2 to get the next number. So you add 2 to get the next number. So that's the pattern. The recursive rule is you describing that pattern. And the pattern is not so much that I'm adding 2 each time, but I have to learn how to describe 2 numbers in sequence like that. And if you go back to this I showed you over here, But the subscripts just tell you position. This is the number in the sequence. It's arithmetic. That means I'm going to add or subtract a number to this to get that. So this is a number in the sequence, 3. To get from position 3 to position 4, I need to add the answer to position 3, a plus 2, to get to this one. So we use these notations right here to write our rule. Tell me where to start, and then tell me the pattern. The next number in the sequence is the previous number in the sequence, right? This is the number before that one. A sub n minus 1 is the number before that one. And then add the common difference. This is how you write a recursive rule. This is the next number in the sequence. This is the number, the previous number in the sequence. And this is the common difference. So in the sequence we just did, with the 3, the 5, the 7, the 9, and so forth, the rule for a recursive rule for this sequence, which we know has a common difference of 2, so D equals 2, I would write A sub 1 equals 3. That is my starting position. And then A sub n equals the previous answer plus 2. That is your recursive rule. Both parts. So that's how you would write that. You need both parts to write the rule properly. A lot of times people mess up and they only give me that part, the bottom one. That's not enough. You got to give me where to start. And so that is the stuff I want you to know. We're now going to do some practice problems with that.